Hello, my name is Muhammad Asfaw Abdullah. You call me Asfa. So my entry number is DE180.7. So my group member consists of Aidil Firdaus bin Abdul Razak and then Muhammad Firdaus bin Ahmad Rofi. So basically we're gonna present our task, which is recycle the material classification by using convolutional neural net, which is CNN. Okay, before we answering the task question, we go to for introduction first. So, convolutional neural networks are commonly used in voice recognition, language modeling, and lastly, video processing. So, activity identification remains a difficult topic for major research initiatives over the last few decades. One of the problems is impacting of implementation of this technology in clinical environment is sensor embodiment, and second one is a poor precision of behavior detection. Next, CNS comprise of three types of layers, such as convolutional layers, and fully connected. The convolution operation extract different features of the input. The higher the level of layers, the extract higher the level of features while pooling layers. Also called the subsampling or downsampling is to reduce the dimensionality of each feature map but retain the most important information. What about spatial pooling? Spatial pooling. Spatial pooling can be of different type of such as max, average, and sum. In case of max pooling, we define as the spatial neighborhood. The term of fully connected is implies that every neuron in the previous layer is connected to every neuron on the next layers. The output from convolutional and pooling layers represent high level features of the input image. So the purpose of the fully connected layer is used to these features for classifying the input image into a various classes based on training dataset. Same like our task. So we need a dataset which is our picture, can, and pet to differentiate between these two, which is can or pet. So here we can see the pros and cons. Pros is the accuracy in image recognition. So as mentioned before, in introduction. So next is cons. The cons is if you don't have a good GPU, they are quite slow to train. So this is related to our task, which is we use a Google Collaborative to run this program. So my GPU is quite slow to run the code. So it takes a long time to render all the codes. So next is need a lot of training data. So basically, you know that data have been provided by lecturer, which is a can and pad. So we need to differentiate between these two, can and pad.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aidil Firdaus bin Abdul Razak, DE180128. For my part, I will share to you guys about the methodology, result, and analysis. For the methodology, we have two tasks. The first task, we must create the model of M1, but it doesn't mention if we cannot use the p-train, so we go to the two model. The first one is only sequential model, is the main model, and the second one is sequential model with p-train VGG16. For the task 2, we must use another p-train, but we constant the sequential model. So the first, we use a densenet 1 to 1 as our p-train, and the second one we use a resnet 50. The data that we'll get is two, which is we have a training data and validation data. For the training data, we have two category. The first one is a can, we have 156. For the pet, we has a 310. So the total up for the training data, we has a 466. And for the validation data, it has a 77 for the can, and pet is a 133. And the total up for validation data, we has a 210. To the test data, we has a three picture, and each picture has their own category, and it must have the can and bottle in that picture. We can use a 1.5 liter or 0.5 liter bottle. The first category, it must side by side, means can and bottle must side by side. And second one is a bottle front the can about 10 centimeter until 15 centimeter. And for the third one, we switch it, each can in the front and the bottle in the back. The range is same, is 10 centimeter until 15 centimeter. This is our three picture for the test data. We have a side by side and a can in the front and a bottle in the front. Now we go to the result and analysis, to the demonstration. We use a Google Colab to run this assignment. So for this one, we must connect, and then we must connect to our Google Drive. And this time I use my Google Drive, so I save the file at assignment 2. It's right here. So the step 1, we must connect to Google Drive first, and then we run it. And the step 2, we must dataset directory, so we run. And step 3, we create a trend and validation data directory, so we run. And this time I share the location that I save, so this is the variable to calling is right here, and this, and it will print the data right here. And we can see that cane for training we has a 156, pet 310, and for the validation can is a 77, and for the pet is a 133. And the first, we run here to input the TensorFlow. And the step 4 right here, we must construct the ZM model. So at this time we use the input shape is 150 times 150 times 3. 3 is because the picture is a color as a RGB layer. And for the convolution 2D, we use a 8, 16, 32, 64, and 128. And for the max pooling is a 2 times 2, and the dense layer is a 512. So the output, it will show like this, to see the layer and output shape and parameters. And the total parameter that this sequential, it has 361,553, and all this is a trainable parameter. So for the this step, we ignore first, which is a p-train model with VGG. So we just go to the step 5 to pre-process the input data. And this time we use a batch size about around 2, and the target size is 150 and 150. And this is our output. And for step 6 is a start training process. So we run of it, and it will take a little bit of time because it is first time we train this model, so it will take a little bit of time. So we use a step per epoch is 100, and it must same with the validation step, and we use 100 too. And for the epoch we use 20, so it will repeat with 20 times. So we wait until it finish. Now we finish our starting process. So we go to step 7 to plot the outcome right here in a graph. So this is our graph as we get for the sequential model only, and this is the best training we get. So now we try run with the pre-trained VGG16. This is our graph for the sequential model with pre-trained VGG16. Two graph before is a graph without the test data. Now we write a test data is right here. So okay, then we run the step 3 and we run right here 2. Then we run the CNN model, and this time we don't run the pre-train first, so we just go to the step 5. Then we go to the start training process. Now we plot the outcome right here. So as we can see, this is our graph for the sequential model with test data. Now we try to run with the pre-trained VGG16. So we just run right here. Go to the final step, which is plot the outcome. So we will get this graph, and this graph with the pre-trained VGG16 and the test data. The first pre-train we use at the test 2 is a DenseNet 121. The step is same with the task 1. We just run here and run, but at this part we must change the VGG16 right here before to the DenseNet 121. Then after we run of it, this part 2 we must change from VGG16 to the DenseNet 121. And after we run of it, and we will get the data is right here, is our graph that we will get from the training process, and this is graph for the DenseNet 121. And for the ResNet, we just change at the this part 2 from the Dense 121 to the ResNet 50, and this part 2. Then the result that we will get is like this. Now we can compare of it. This one is for the ResNet 50, and this one is for the DenseNet 121, and this one is for the VGG16. That is from my part. Now we go to the my friend. Thank you.
Assalamualaikum. My name is Muhammad Firdaus bin Ahmad Rafi, and my metric number is TE180094. So I am going to continue the presentation with conclusion. So we have achieved a good fit results. A good fit results is neither overfitting or underfit result in both task 1 and task 2. So underfit is when we have high training and high testing loss. while an overfit model will have extremely low training error but a high training loss. Next, batch size controls the accuracy of the estimate of the error gradient when training neural network. So the default batch size was 32, but we decided to change to 2 because smaller batch size are noisy, offering a regularizing effect and lower generalization error, and make it easier to fit one batch worth of training data in one memory. One epoch means that each sample in the training data set has had an opportunity to update the internal model parameters. So an epoch is comprised of one or more batches. The number of epochs that we found suitable was 20. For model M1, the training and validation accuracy almost achieved 100%, while for training and validation loss achieved 0% when test picture is fed to the model. This proves that when the test picture is fed to the model M1 can differentiate the pictures. For task 2, pre-trained model DenseNet 1-to-1 had the best accuracy for training and validation because training and validation accuracy achieved 100%, while for training and validation loss achieved 0% when compared to ResNet 50 and model M1, which both of them have a little fluctuation. So model DenseNet 1-to-1 has the best good fit. Next, recommendation. So for the CNN that we have produced in this project, it can be implemented in the recycling center to make it easier for the separation of material. For this project, it can only differentiate between two items, which are plastic bottle and can. For future work, the CNN can identify and differentiate more material that can be recycled, such as aluminum foil, plastic bag, and paper. So that's all from us. Thank you.